Hello, grade 9 science class. I saw some students having trouble understanding how to count the atoms, so I'm just going to go over some examples here of counting atoms. And we're going to zoom into one focus here with magnesium phosphorate. So it's a type of molecule. So all these atoms, these individual atoms, make a molecule. Okay, molecule. And one atom by itself is just an element, okay? How do we know that this is an element? Well, if we look through our periodic table, you zoom into the fine Mn, and we notice that it is an element on our periodic table. The uppercase M goes with the lowercase n, okay? We wouldn't just leave the n by itself, because if you were to look on the periodic table, you would not find just a uppercase M. We have magnesium here, but no just regular uppercase n. So we have to go back here, and we know that this is an element by itself. And same with P here. P is just uppercase, so it's by itself. There is no lowercase letter to it. So P, if we look for P here, we do find it on the periodic table. Again, P is phosphorus. So that's one element, again, by itself. And then if we look at oxygen here, again, it's a capitalized letter. It isn't P lowercase o. That is something totally different. They are capitalized. So that's oxygen, an element on its own, which you can find that on the periodic table. Oxygen. So now we're going to count these elements and how many atoms there are, okay? So let's write down Mn. How many is there? Well, there's only one atom, okay, of Mn. And we can see that because it's just one. There is a little 1 here, but we don't usually write that down. P, how many atoms? Again, there is only one atom of phosphorus. And now if we look at oxygen, it has a subscript, okay? That number, that smaller number located to the right-hand side of the element is a subscript. And it tells us how many atoms there are for just this particular element, okay? Because it's right beside it. So oxygen would have 4 atoms. And then your total number of atoms, total number of atoms would be 1 plus 1 plus 4 is 6 atoms in this molecule right here, MnPO4. So a total of 6 atoms is what this molecule has. Let's look at this example here. H2SO4, so we know that these are subscripts, and they're only associated to the one element that it's right beside. If it was in a bracket, it would be something else, which I'll go over that example. So which ones are the individual atoms? Well, all the uppercase letters. We got an H here. That's an element. So if we look at our periodic table, we'll find H in the periodic table. S is also uppercase, and it's right beside an O. So some people think it's right together. But if you go to the periodic table, you will not find 2 capital S and O's on this periodic table. But you will find a capital S by itself and a capital O by itself. So those are individual atoms of that element. So when we write that out, H equals 2 atoms, because again, that subscript is associated just to the H. It's right beside it, saying that there's 2 H's in this molecule. Now, if we look at S, write down the individual element, and how many atoms does it have? It's just 1, because there is no number associated beside it. It's just 1 atom. And now we write oxygen. It has a total of 4 atoms, because that subscript is applied to just the oxygen itself. So what does that mean? We have a total number of atoms to be 2 plus 1 plus 4, which equals 7 atoms found in this molecule. 7 atoms found in the molecule H2SO4. So let's go into another example here. SrClO, which is in brackets, and the 2. Oh no, what do we do? Well, let's identify which ones are the elements from the periodic table. So Sr is an element. As you can see, it's a capital S and a lowercase r. So those have to stay together. So lowercase letters stay with their uppercase ones. So on the periodic table, let's find Sr just to double check that it is an element. Okay, Sr, here it is, strontium. Sr, perfect. So that is an element, and it will be an individual atom that we are counting. So Sr equals how many elements? Just one atom here. Why does this 2 not apply? Because the Sr is not in the bracket of ClO, okay? So this 2 only applies to everything in the brackets. Okay, 2 only applies to the O and only applies to the Cl. Okay, now let's look at the Cl. Cl, uppercase C and lowercase l. So that means they have to be together, okay? Cl, lowercase l. How many atoms are there? Well, Cl, double check if it is an element. Uppercase L, uppercase C and lowercase l, well, we do see it. It's chlorine, okay? So that's an actual element. So let's go back to our worksheet to make sure. And then we know that uppercase O by itself is indeed oxygen. So how many elements are here? Well, we know with those 2 elements being in the brackets, the 2 applies to both elements. So 2 times 1 chlorine, we get 2 atoms. So when it's outside the bracket, we have to do multiplication. So multiply. Okay, 2 now times the 1 oxygen that's here. Well, 2 times 1, you get 2 atoms of oxygen. And now our total amount of atoms is 1 plus 2 plus 2. We get 5 atoms. Awesome. Let's move on to another example. Again, you can pause at any time to practice the example before I go over the answer so that you get definite practice, okay? So now let's look at this. What's going on? We got a 5 that's super big right beside the C. Well, in class, we mentioned that this super big number right beside or to the left of the element is called a coefficient. Okay, so coefficients will also be multiplying throughout the entire molecule, okay? And if there's already a little number right here for oxygen, as we can see, we're going to be taking that 5 and multiplying it to the subscript, okay? So, which one is a definite element? Well, uppercase C with no lowercase letter. Again, we go through our periodic table, look for uppercase C to make sure. Well, there it is. It's carbon. So, uppercase C is an element on its own. So, C equals, now how many atoms are there? Well, C times by 5. So as well, if this big number is right beside the element, that is still multiplication. So you still multiply. Okay, it's very important to know that you're still multiplying. So 5 times the 1 carbon that's already there, you have 5 atoms of carbon. Now, let's look over to this oxygen. We know that oxygen, a big O with no lowercase beside it, is an element from the periodic table. So oxygen, how many atoms are there? Well, 5 multiplied by the 2, that's the subscript right beside oxygen. Again, this subscript 2 does not apply to carbon because it is not in brackets, okay? Therefore, the 2 only applies to the oxygen. So 5 multiplied by the 2, you would get a total of 10 atoms of oxygen. Now, what is the total atom count of the entire molecule? Well, 5 plus 10, we get 15 atoms. So that's your answer there. Let's look at another example that might be a little bit more difficult. So if we move on here, we got brackets And we got similar elements that are separated, but we're going to go over that, okay? So which one is an element on its own? Well, let's look here. Capital H is right beside a capital N. So we know that N is not a part of H. So H, as we know from the periodic table, is hydrogen, okay? And you can check on your periodic table. There is just a capital H and it's hydrogen. And how many are there in this practice problem? Well, there's a 3 right here. However, this 3 only applies to everything that's in its bracket. So this 3 does not apply to the H, and therefore we know there's 1 atom of hydrogen in this molecule. Now let's look at the next one. Na. Oh, wow. Okay, so N is capitalized with a lowercase a, and they have to stick together. So if we look at our periodic table to make sure it's an element, Na is indeed an element. It is sodium, okay? So how many molecules of sodium are there? Well, let's look here. Sodium, there is no subscript beside it, which means that it's just a 1. That means there is only 1 atom of sodium. Okay, let's focus on the brackets now. Well, we see a capital C, perfect, capital C, no lowercase, so that means it's just C by itself. And we know that's carbon. So how many carbon molecules are there in this, carbon atoms in this molecule? Well, look at the 3 here. The C is in the bracket, so the 3 does apply. So 1C multiply, again, multiply is very important, by the 3. So 1 times 3 equals 3 carbon atoms that are present. Now, let's go on to the next one here. Oxygen. We have that capital O, okay? Oxygen already has this 2 that's attached to it. Therefore, when we have a 3 outside in the bracket, we have to multiply the 3 by the 2, and it gives us oxygen equals a total of 6 atoms, because I went already with 2 times 3, so multiply to get that total number of oxygen. So our total number of atoms in this molecule is 1 plus 1 plus 3 plus 6, and you'll get 11 atoms. So far, so good? Okay, so let's move on to here. This one is an example of an element or molecule where they placed it out so that you can see all the elements, but you can actually combine it, except this is just a proper way of putting the formula for this molecule. Sometimes you'll see in acids and bases replicas of C's and H's. So that's what we see here. But we just add them together when we're counting the atoms. So C, both of them are uppercase with no little letter, so no lowercase letter beside it. So we know it is a carbon atom. And how many are there? Well, there's 1 here and 1 here, so that makes it a total of 2 carbon atoms. And now we're going to look at the H. Again, it's a capital H with no lowercase letter beside it. But over here, we also have a capital H with no little letter beside it. So we just add them together. And there's 3 H's here plus the 3 H's here. Because again, this 3 only applies to the H here, and the 3 only applies to the H here. So therefore, we're not multiplying the 3 over. If the 3 was, let's say, in brackets over here, then we would apply it. But it's not in brackets, therefore the 3 only applies to the H. And H, as a capital letter, we know is hydrogen. So again, 3 plus the 3 here, we get 6 atoms. So this is an example where you would add the different atoms. But when you have the subscripts beside, you would multiply it, okay? So it's different when there's brackets, and coefficient, again, that's also multiplication, okay? Now let's look at our next letter, which is the O. Is there any more O's in this molecular formula? No, there isn't. There's only 1. So we know the capital O, or capital O, equals oxygen. It is an element, so there's only 1 of them, so 1 atom. And now what is the total? The total equals 2 plus 6 plus 1 equals 9 atoms found in this molecule. So I hope this video clears some of your questions up and shows you when to multiply and when to add. But usually you're multiplying, especially when you have a subscript outside of a bracket, okay? Or when you have a coefficient, you also multiply throughout, okay? So see you in class, and come with any questions that you may have. Have a wonderful day. Thank you.